GCSE question of the week 17, foundation question 1. So we've got the total surface area of a cube is 150 square centimetres. Find the volume of the cube. So this question's really testing whether you understand the difference between surface area and volume, and whether you know what a cube is. So a cube, what do we know about a cube? Well, it's a cuboid, 3D shape or solid, okay, with all of the sides the same length. So all of those sides have the same length in a cube. And what's the surface area of that cube? Well, the surface area is not the same as the volume. The surface area is the area of that face plus the area of the corresponding face behind the cube, if you like, plus the area of that face, plus the corresponding area below the cube, same as that one, plus the area of that face, plus the corresponding face that's the same as that one on the left. So how many of those faces have we got? Because we know they're all the same in a cube. The area of those faces is all the same. And how many have we got? We've got 6 of them. If you count them up, you should be able to check we've got 6 faces. So maybe we could work out the area of one of those faces. We can do that because we know that 150 square centimetres is the total surface area. That's all of those 6 faces areas added up. So if we divide by 6, that should tell us the area of one of those faces. So what do we get? 150 divided by 6. Maybe we could divide by 3, that gives us 50, then divide by 2. I think that's 25 square centimetres. Okay, so we know the area of one face is 25 square centimetres. Now let's focus on one of those faces. So if that's our face, and we know its area is 25 square centimetres, how would we work out an area of that shape? Well, it's a square, so we do this length times this length. Whatever that length is times itself has got to give us 25. In other words, if we found out the square root of 25, or what number times by itself makes 25, that's going to tell us the side length. So I think the square root of 25 is 5, so 5 centimetres must be our side length in this cube. So we've got 5, and because it's a cube, we've got 5 there and we've got 5 there. So that's the key. We've found out the side length. Now we can find the volume of the cube. And how do we work out the volume of a cube? Well, the volume of a cube is just that 5 times the 5 times the 5. So the length of all of the sides, or the 3 dimensions of the sides multiplied together. So our volume of a cube is going to be 5 times 5 times 5. And I think 5 times 5 is 25, times 5 again, we'll get 125. And this time our units are cubic centimetres, because we've got a volume. Done. Right, foundation 2. The base length of the semicircle is 8 centimetres. Right, straight away I'd be annotating my diagram, so I can make sense of this question. So the semicircle, what does that mean? That means the half circle shape. That's this one. And we know that the base length of that semicircle is 8 centimetres, so I'll label that. Inside the semicircle there is a circle that touches the edges of the semicircle. Show that exactly half of the semicircle is shaded. Okay, so hopefully you're realising that we've not covered any direct way to work out an area of this weird blue shape here. We can't do that straight away, but what we can do is work out the area of the semicircle. And then if we could work out the area of the circle inside it, we could take that away from our semicircle area, and that must leave the blue area that we want. So that's what we need to do. So step number 1, let's try and work out the area of the semicircle. Okay, so again, that means that shape. Area of the semicircle. Right, how do we do the area of the circle? Well, area circle equals pi r squared. And if you don't know that, you've just got to learn it. You need to go into the exam knowing that and many other formulas. So area of a circle, pi r squared. So what's the area of the full circle? Well, that's going to be pi times the radius squared. Now we've got to be careful here. The radius is not 8, because remember that's the diameter of that circle. So we need to halve that, which is 4, and we're going to do pi times 4 squared. And that's going to give me 16 pi. 16 times pi. Now your calculator might leave it as that, and in this calculation we actually can. Okay, if you press S to D, you're going to get a decimal number as well. Let's just leave it like that for a minute. That's the area of that whole circle. Therefore, the area of the semicircle, semicircle is going to be half that, because if we know the whole circle's area, we find half of that, it's going to tell us the area of that semicircle. So half of 16 pi, that's going to be 8 pi. Number 2, job number 2, not number 2, job number 2. Okay, let's work out the area of the white circle inside. So we want to work out this area here. Okay, the area of that white circle. Let's do that. We're going to use the same formula again. So this is the area of white circle. We're going to use pi r squared. But this time, what's the radius? Right, well, we need to think here. Okay, it's not labelled on my diagram, but I know that the diameter of that blue part was 8 centimetres. So if I imagine that whole circle again, the arrow that I've just added must be the radius of that entire circle. We know the diameter of that circle is 8, so I think that must be 4 centimetres. The diameter of the white circle is 4 centimetres. Okay, so we need to do the same thing as we did before. We want the radius, we know the diameter, so half that 4 centimetres is going to be 2. Our radius is 2. So the area of that white circle is pi times 2 squared. And that's the same as 2 squared is 4, so we get 4 pi. Okay, let's go back to the question. Show that exactly half of the semicircle is shaded. Well, we're done. Oh no, we're not done, beg your pardon. Job 3. Okay, let's just be clear. Right, this is the area of the semicircle. This, number 2, is the area of the white circle. We've still not worked out the area of the blue shape. So the area that's blue, remember we said at the start, we've got to do the area of the semicircle, which is 8 pi, take away the area of the white circle, which is 4 pi. Therefore, the area of the blue circle is 4 pi. Show that exactly half of the semicircle is shaded. Well, now we've done, because we know that the area of the blue is 4 pi, and the area of the whole semicircle is 8 pi. So what fraction is shaded? Well, we've got 4 pi out of 8 pi. You could just look at those numbers and say that, well, 4 pi is obviously half of 8 pi. If you wrote that as a sentence, it'd be fine. As a fraction, 4 pi over 8 pi, pi's cancel, 4 over 8 is the same as a half. Okay, so the fraction of the semicircle that's shaded is 1/2. Proved. Proven. Done. Okay, question 3. Now these group frequency tables are quite common, and it's easy to not quite understand what they're representing, so we'll go through this quite slowly. 25 pupils were given a puzzle to complete. The table below gives the times taken. Estimate the mean time. Right, so the first thing we need to know or understand is what this thing here represents. So this is giving us a range of times. It says that time taken is less than or equal to 15 seconds. So it can be up to 15 seconds, including 15, and that time, if we read backwards from the middle, is greater than 5 seconds. So really it's saying the time somewhere between 5 and 15 seconds, but it cannot be exactly 5 seconds, it can be exactly 15 seconds. Right, so it's a range of times. Okay, we call that a class. So this range represented here, we can call a class. And what does this frequency word mean? Well, this means the number of times. So if we put those two things together, it's telling us that we've got 7 times that are between 5 and 15 seconds. Okay, so we've got 7 times. We don't know any of the times exactly. Now let's imagine that we did. Let's imagine we knew exactly what those 7 times were. So maybe they were 6 seconds, 6 seconds, 10 seconds, 11 seconds, 12 seconds, how many got? 1, 2, 3, 4, 5, another 12 seconds, and 15 seconds. Okay, those would all fit the bill. They're 7 times, and they're within our range of 5 to 15 seconds. And we can have 15 because it says less than or equal to. We couldn't have had a 5. Now, I know we've got other class intervals to worry about in a minute. But let's imagine that was it. We just got those 7 times. How would we work at the mean? Well, you'd all know what to do then. We'd add these numbers up. Okay, we'd find the sum of those, and then we'd divide by the number of times, which is 7. So we do 6 plus 6 plus 10 plus 11 plus 12 plus 12 plus 15, and we divide by 7. Alright, so if we knew the times, you'd probably know exactly what to do. Okay, but we don't know any of the exact times. So we need to rethink. Well, we know that 7 of the times are within that range. Okay, and it wouldn't make much sense to guess that those 7 times were all 5 seconds, because that's the minimum in the range. Actually, it'd have to be 5 point something, wouldn't it? Not exactly 5. Equally, it wouldn't make much sense to assume that they were all 15 seconds. So what would it make sense to assume? Well, it would make sense to assume that, okay, those 7 times are right on the midpoint, the average, okay, between the 5 and the 15. Okay, and what's that? Well, it's 10. So the midpoint of those classes or those ranges is going to be really useful, because the midpoint of the first range is 10. It's halfway between 5 and 15. 15 to 25, it's going to be 20. Midpoint 30. Midpoint 40. Midpoint, that last one should say 55, shouldn't it? I think that must have been an error on the question, sorry. I'll have to change that at school. I think that should be 55. Anyway, right, midpoint 50. Okay, so we go back to our first one with 7 times, right? We're saying that 7 times we'll assume at the midpoint. So we've got 7 times of 10 seconds. That's what we're really saying. We'll assume that those 7 times all fall at 10 seconds. That makes sense as the middle of those values. So what would the total of those times be? Well, it'd be 7 times 10. So if we do the frequency times the midpoint, 7 times 10 is going to give us 70. So we're really saying there that those 7 times, if we assume they all have a time of 10, gives us 70. What about those 8 times in the next range or the next class? Well, 8 times 20, that's going to give us 160. And same thing on the next one. We're going to get 180 from 6 times 30. The next one, we're going to get 3 times 40, that's 120. And the next one, we've got 1 times 50, which is just going to give us 50. Right, so what are the total times? Well, we said for those 7 at the start, the total time was 70. So what's the total time in all of those classes? Well, we've got to sum this last column. Okay, we're going to do 70 plus 160 plus 180 plus 120 plus 50. Okay, now we can do that in our head, so we can do some column addition. We've got 7, 13, 21, 28, I think. And then we've got 1, 2, 3, I think it's 580. Okay, so if we add those together, we get 580. 580 seconds is the total of all of the times added together. What are we going to do next? Right, well, in a normal mean, you said we'd divide by how many times there were. Okay, so how many times are there? Now, a really common mistake here would be to say there are 1, 2, 3, 4, 5. We'll divide by 5. But remember, this is saying we've got 7 times, plus 8 times, plus 6 times, plus 3 times, plus 1 time. So the total number of times must be the sum of those numbers. So we've got 7 plus 8 is 15, 21, 24, I think that's 25. Okay, if we add those together, we get 25. So we're going to divide by the number of times. That is not 5, it's 25. Right, that's going to tell us our mean, 580 divided by 25. Now we could use bus stop method here, or we could try and be a bit clever. Right, if I could get that denominator to 100, that'd make my calculation a lot easier. So let's try and do that in a couple of steps. If I double the numerator and the denominator, I think I'm going to get 1,160 on the top, and I'm going to get 50 on the bottom. Okay, and if I do that again, I'm going to get 2,320 on the top, and I'm going to get 100 on the bottom. So now I've got 2,320 divided by 100, and that's nice and easy. I can just imagine my decimal point moving to the left twice. I'll get 23.2. So the mean time is 23.2 seconds.